As we walk, the foot can be easily planted directly under the body's centre of mass, and thereby support the entire body weight as it shifts from leg to leg during forward progression with an efficient recycling of energy between steps. Humans are characterized by highly extended knee and hip postures. The ankle is also modified for supporting the entire body weight, and a shock-absorbing arch helps the foot to cope with this added load. In addition, the big toe is no longer opposable and is in line with the other toes and serves as a propulsive lever for upright walking. Therefore, the fundamental unique characteristic of the human foot is that it facilitates upright bipedal walking. In order to achieve this, it's useful to consider the three principal pivotal points which allow forward progression whilst the foot is in contact with the ground. They are the underside of the heel, the ankle joint, and the great toe joint. The human foot appears to be unique in that it only has these three pivots. The implication is that losing any of these, or gaining an extra pivotal point, is likely to have significant consequences, resulting in a disruptive sequence of joint movement. This may reduce efficiency or eventually produce painful symptoms in the lower limb or within the foot itself. The first part of the foot to strike the ground during walking is the heel, the rounded underside of which allows the continued forward progression of the body whilst the plantar surface is lowered to be fully in contact with the ground. This movement is controlled by leg muscles that serve to decelerate this action and allow for a controlled acceptance of the body's full weight. As the body moves over the weight-bearing foot, pressure shifts towards the forefoot. The superior surface of the ankle bone, or talus, is shaped in such a way to allow this to happen and gives about 10 degrees of forward movement. This triggers a progressive muscular contraction in the calf muscles that generate a downwards push against the ground. This push increases as the heel leaves the ground, leaving the forefoot and toes as the only point of contact. The forefoot joints extend as it generates the greatest force against the ground, and the heel continues to lift further from the weight-bearing surface. What is often overlooked is the significant ability of the first toe joint to bend and act as a final pivot around which the whole foot rotates.